Now we just want to talk about a couple properties of summation. So let's go ahead and expand this sum here to see if we can see what happens when you take a constant multiplied by a variable. So this would be 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. Okay, so notice we stopped here at 5. Now what you can notice here is that this 3 is constant in each of these options. So we can actually factor out the common factor of 3 from this sum, and we're going to be left with 3 times 1 plus 2 plus 3 plus 4 plus 5. Now if we were to rewrite this using sigma notation, we could actually write it as 3 times the sum of I, where I went from 1 up to 5. Okay, so the point is the constant property says the sum, as I goes from 1 to n, of k, a constant, times some function of I is going to equal that constant times the sum, as I goes from 1 to n, of that function f of I. Okay, in other words, when you see a constant times a function, you can factor out that constant and then take the sum. So it makes your multiplication and addition a little bit easier. Now, in our next example, we have the sum of a function which is represented by two different terms. So basically we can see this as two different functions here. We have a j squared function and a negative 2j function. And so let's go ahead and expand this out so we can see what's happening. So our first term here is going to be 1 squared minus 2 times 1. Our second term will be 2 squared minus 2 times 2. Our third term is going to be 3 squared minus 2 times 3. And our fourth one, okay, because we're going up to 4, is going to be 4 squared minus 2 times 4. Now, because this is all addition and subtraction, notice I can rearrange the order of all of this. So I could put my 1 squareds, 2 squared, 3 squared, and 4 squared all together. And then I can also rearrange all my subtractions. So minus 2 times 1 minus 2 times 2 minus 2 times 3 minus 2 times 4. So what you can see here is we could separate this sum into two different sums. And so what I could write here is the sum as j goes from 1 to 4 of the function j squared, and then plus the sum as j goes from 1 to 4 of, well, these guys right here, which would be negative 2j. So hopefully you can see that this sum belongs to this set and this sum belongs to this set. So in essence, the sum and difference property says if you have a sum from j going from 1 to n of two functions added or subtracted, you can actually separate those functions out, find the sum of each one separately, and then add them together. So there would be the sum of f of j, and then plus or minus the separate sum of g of j.